Hi, everyone. My name is Anka Udoc, and I would like to welcome you at today's webinar, Food and Beverage, Saving Through Digitalization. Thank you for joining us today. Let's see today's speakers. First, we will have Dalibor Bobic, Managing Director and Zenon Sales Engineer from Exor AT Belgrade. We have two guest speakers joining us today, Bojan Šebić, Project Manager from URAM System in Serbia, and Matej Mučnik, Automation Manager from Indbas, Slovenia. We have also Nikola Maric, Zenon Technical Support Engineer from Exor AT Slovenia. And this is me on the left. My name is Anka Udoc. I will be hosting the webinar, and I'm Marketing Manager from Exor AT Slovenia. So let's see what's on the agenda today. First, we will hear a little bit about Exor AT and Copadata company profiles. Later on, we will talk about MTP, modular production, and line management. After that, we will listen to our guest speaker, Bojan Šebić from URAM System, who will talk about energy management system in Carlsberg, Serbia. And after him, our second guest speaker, Matej Mučnik from Indbas, will show us Inspector, a system of sampling and quality control integration. Last thing, we'll be reporting with Zenon. And at the end, we will have time for Q&A sessions. So send all of your questions to the Q&A box. We will answer them during the webinar or at the end of the webinar. This webinar is also being recorded, and you will receive the recording in the following days to your email address. Also, when the webinar will finish, a survey will pop out into your browser, so please fill it out. We want to see your comments and your feedback. Okay, I suggest we start. I would like to invite our first speaker, Dalibor Bobic, who will talk about Exor AT and Copadata company profiles, MTP, and line management. Welcome, Dalibor.
Thank you, Anka. Okay, greetings from my side too. And for the beginning, as Anka mentioned, just to introduce our company, and let's say that we are software and hardware distributor and representative of 9 companies, well known for industrial automation. So we are doing business with 3 offices in South and Eastern Europe. So in Balkan region, our offices are located in Ljubljana, Zagreb, and Belgrade. And we have 15 employees and more than 500 customers in the region. So we are present in different areas, starting from energy and infrastructure, automotive, food and beverage, which is today's topic, of course, pharmaceutical, and all other parts of automation. Speaking about Copadata, we are, of course, representatives of Copadata for more than 10 years now, and Copadata is doing software development, well-known Zenon software platform, and together with us, we are doing software sales in the region. Of course, Copadata is doing this globally. We have technical support and doing technical support together with Copadata, and trainings, and different kinds of trainings and certifications for it. So Copadata has more than 300 employees worldwide, and its business started in 1987, so more than 30 years of development of Zenon software platform, and up to now, more than 5,000 successful customers. Speaking about Zenon, just briefly, at the beginning, it's a software platform that makes all our lives easier in terms of automation. So starting from scalability as a main functionality in Zenon, you can start really small projects and broaden them up to high-level SCADA and even more. Security is also a very important factor for this, and flexibility in terms of how many different areas, different machines or parts of your production you can connect. Of course, ergonomics is a big part, and interdisciplinary nature, so you can connect different systems in one system. We are proud to show some of our most important customers. We will speak about machine builders also today. We will speak about food and beverage companies, A lot of them are present also in our area, and we have really nice projects. Some of them you will see during this webinar. Speaking about Zenon, when it comes to food and beverage, we have so many goals here to improve control and efficiency, of course, of the whole production, to lower the consumption. That's why we are talking today about savings, to raise quality and to improve flexibility through different options that Zenon can provide us with. So different applications that Zenon can do, starting from HMI in every single machine. So it can be also for machine builders, the main solution for their HMIs. Continue with process control. So globally speaking, all processes can be controlled through Zenon, like supervision, like standard SCADA project, and going through energy management. We will see today our reference from Uram system with Carlsberg energy management, different kinds of analysis and reporting options. At the end, we will see what we can provide you with when it comes to really nice and complex reporting. Of course, we are caring about different people in the production, starting from the workers in line and up to management level. So with different options for every single level of management in the factory. Areas, we are covering almost every single area in the production, including the infrastructure. So we are not speaking about the processes in the production, we are speaking also about the building management system and utility area and so on. Okay, perfect continuation is MTP, something new, relatively new, but of course MTP just started to develop into standard. But we wanted to introduce this terminology and this solution to our customers in our region. So speaking about MTP, for those of you who are familiar with this terminology, most important thing is that Zenon is MTP ready. For those who don't know what it is, we can say that we can do already projects using MTP. So this is modular type package solution for using different machines, not as a machine. We are looking at machine like a service, let's say, for every single part of machine, we can reconfigure it and use it in a different way. So MTP started to develop in 2015. And Copa Data is following, of course, this cutting-edge technology all the time. And already, as I mentioned, there are some projects developed using MTP, not just in the pharmaceutical and chemical industry. That's why we are today speaking about food and beverage. This standard is becoming more important because of the flexibility of using the machines in the production. You can use it more flexible, and I will speak more about this today. What are the advantages of this modularization? So faster time to market. When you are doing a changeover, when you're doing different products, you can easily just change the services, change the procedures inside the machine and inside one production line, and do the approval of these steps, and you can shorten the time up to 50%. A lower production cost, of course, you saving time and saving money with this changes going on in the production. You can lower your production cost up to 40%, which is enormous amount of costs. Increased flexibility. I already mentioned that you can easily change the processes in your machine and use it in a different way, be ready for new product, for new series, and you can increase up to 80% of production of flexibility of your production. Let's go into a little bit into more details today. What is MTP? What is modularization? When we speak about MTP, we are speaking about the similar thing as we are using long time now, so like a driver in our office PC. If we want to connect to a printer, we are using native driver for this printer, automatically downloaded and installed, and we can use printer for scanning, printing, even fax. And this is something similar to MTP. We are with Zenon Pole, so this is a process orchestration layer where you can do visualization of all processes. We are connecting to MTP to use different services inside the machine. So we are not looking at the machine as itself, we are looking at its services like heating, mixing, dosing, pumping. This is what we are talking about when we say MTP and modularization. So just using these services, connecting it in a different way, and make everything more flexible. What are the steps from the laboratory to production? Of course, process development, modular process design. We can see all processes, we can configure this modular line, connect everything. So also with Zenon, you have ability to connect different type of equipment, different machines, very easy with drivers, with more than 300 drivers in communication protocol. Next step is to improve efficiency with Pole, where you connect multiple MTPs and make production more flexible, and you can even rearrange these parts of production very easily, and in this way improve flexibility. Yeah, speaking about how this is connected, let's say, so we are at the bottom level, we have machines. Of course, we are speaking about different machines, different manufacturers. Manufacturers also started to provide MTP file with these machines. Even if they don't, we can use our Zenon soft logic to make these MTP like files and use these machines as they are already MTP ready. So we are looking at these different machines on the lower level, looking at all these processes, all information that the machine itself provides. So this is PA layer, so process equipment assembly layer at the beginning. Next layer is Pole, I already mentioned it. So where Zenon comes with with all options about the visualization, and of course all functionalities like historian, alarms, recipe manager, process recorder, this visualization of the whole equipment where you can make changes, make engineering more easy. Of course, this connection, MTP standard, is speaking with OPC UA. This is also supported with Zenon. After this, we are speaking generally about Zenon, so connection to third-party systems or upper-level systems like ERP and MES systems. It's very easy to connect even to cloud. This is a kind of standard connection that Zenon can provide us with. So we are going into IT part of the production. Also, as I mentioned, third-party systems like different applications, and even Grafana, a really nice tool for visualization, different data storages. So not native Zenon data storage, it can be even different one, web engine, web applications, identity services. This is available through Service Grid. We were speaking about Service Grid in our previous webinar, so you can get more familiar with this watching some of our previous videos. So this is Service Grid layer on top of the whole production. Okay, Zenon MTP Suite. What we provide to end customer, MTP editor, when you can edit or create MTP files, so you can read them from the machine. As I mentioned, machine builders are also providing MTP files, so we can read, edit, and create MTP files. We can validate it, of course, based on these standards. We can manage PA instances, so we can configure our equipment. We can change these services inside the machine. We can also make a poll where we can do the visualization, connect these package units, make a project, let's say, itself. PS software suite, so visualizing control of skids, and the MTP gateway. Of course, we are speaking about connecting multiple devices, multiple machines, and this is also a part of MTP Suite. Tasks from MTP file to orchestration. This is just in short, what are the steps? So connecting to SQL database, read MTP files or create or edit it, import and manage in smart objects. This is also important part where we are speaking about smart objects inside Zenon. This is almost exactly the same as MTP file from the machine. So we are using smart objects introduced 2 years ago, I think, where we are making smart objects ready to use for our partners and our end customers like MTP. So you can rearrange it inside the smart object, just like MTP provides us with the information from machine. We can also, of course, create and manage instances of PIA and orchestrate it, connect everything, do engineering with it, and automatically generate process screens. So that's easy. And I mentioned a lot of abbreviations. So in this screen, you can see all abbreviations in one page, so you can get familiar with the terminology that we are using for MTP standard. Yeah, next thing, important thing, it's a natural continuation into line management. Let's speak more about what Zenon provide you with when it comes to line management and protocols and features. I mentioned the different people in different areas and different level. So from line manager, let's say operator in that line, and manager, they all have their own challenges facing every day. We are trying to provide all of them with the solution for all these challenges they are facing. What are the requirements for a line, for this specific line management system? Of course, to have a line under control, to know the machines, to know how to connect everything. Role-based information just in time. We need the information just when we can react. Analysis of historic data to collect, to make deep analysis, and to make decisions according to this analysis. Integration with OT, IT, enterprise infrastructure, I showed already. Then we can communicate with lower and upper systems very easy with our drivers, with our connectors. User experience, of course, all of this should be done, let's say, in a nice graphical way, where our users can easily react and do this analysis in line. Main functionalities, I will not read everything, I will not repeat myself. So connecting all machines, there is a lot of different approaches for connecting machines. Pre-processing, data acquisition, real-time calculations and supervision of all equipment and calculations, KPIs, of course, including OEE, the most important effectiveness, and different reportings. We will see later on how this is done. Okay, integration with ERP, I mentioned several times. The simple architecture example is here. So we have on the bottom level different even PLCs connected directly to the Zenon server, different machines, including different standards for food and beverage, like Weinsteffen standard or OMAC PACML, different Zenon machines for also options for manual data input, and third-party systems, of course. This all can be connected very easily to the Zenon server, and we can connect also visualization in the cloud, and we can make a separate SQL and reporting machine. Further on, ERP or third-party systems easily connected to this, and of course, a lot of different clients, so fixed clients or web clients, mobile clients are also available with Zenon. Speaking about central control room, so this is the final stage, let's say, where we can collect all data and visualize all data in one place, in a nice control room, gathering all information and all analysis, providing the end customer with the information to make changes, to follow the efficiency of the whole equipment. So starting from machine PLCs and HMIs, IT, OT integration, and of course, performance, to follow performance with different tools. How this can be visualized in Xenon, for those of you who are not familiar with the graphical interface, this is demo project where you can see easily the processes in one line. You can see the calculations and different counters. This is energy consumption, and this is available plug and play almost for end customer. Different trend diagrams, different kind of analysis, and big displays for following the key informations like on-screen display in production area. You are probably all familiar with this. Benefits using line management with Xenon, of course, to assure conformity with quality standards and regulations. Control of all equipment is the main factor for further improvements in a factory. So next one is business sustainability and improved profit with this control, of course, and high return of investment for the entire line. We can increase the productivity with all this modularity and all this information just in the right time to react, to change something or to improve something further, and enable people for information-based continuous improvement. Exactly, next step, as I mentioned, is to get this information just right on time. Yeah, for my part, for this introductory, this is all from my side, and thank you, Anka.
Thank you, Dalibor. Very interesting. Okay, let's continue with the webinar. Next is energy management. I would like to invite our next guest speaker, Bojan Šebić from URAM System, who will talk about energy management system in Carlsberg, Serbia. Welcome, Bojan.
Thank you. A second. First, to introduce myself and our company, my name is Bojan Šebić. I'm a project manager at URAM System. I'm also in charge of development of SCADA and HMI systems. We started as a small company way back in 1990s, so almost 30 years of experience in this field of automation. Now we have a team of highly qualified engineers, more than 15 of them, and we have our own team of electricians. So we basically are able to provide our clients with a full solution, basically a current turnkey program. We began with our SCADA operations in 2012. We became the Copa Data Partner Community. In 2019, we became a Siemens Solution partner. As I mentioned, our services are mostly in industrial automation, covering a wide area from food and beverage mainly to irrigation systems, chemical industry, almost everywhere where you can find industrial automation. We are able to provide our clients with technical documentation, cabinet building, PLC, SCADA, and HMI software, also training, commissioning, and technical support. But to get on with the topic at hand, Carlsberg Brewery was initially called Brewery Celarevo in 2003, and in 2005 it became a part of Carlsberg Group as under the name of Carlsberg Serbia. One of the key initiatives they have is sustainability, and having that in mind, the project of energy management for them means to keep pace with modern technologies. Environment is proving to be ever more important topic at this time, preservation of natural resources. So we provided them with our energy management system software called URAM System Software for Energy Management. It's based on the Zenon software platform. What are the usual tasks for energy management? First of all, in close contact with the people from Carlsberg, we first have to define what is it they need to monitor, to have constant access at any given time. So we first define the measuring points, whether it's electrical energy, water consumption, gas consumption, and then we have a look at what they have installed in their facilities, and if needed, we procure and install additional equipment. Being that those factors are almost, as a rule, pretty widespread, we need to connect all the measuring points into one system, into one network. And once we have that, we begin the development of the application software based and in accordance with the user requirements. Thus, also always having in mind the sustainability focus and supporting their initiative of zero waste water and zero carbon footprint. So what are the highlights of an energy data management system? First and all, you have the automated acquisition of data. You don't have to send people for hours and every day to go and visit each metering device, write it down, and then analyze the data. You have it all already pretty much chewed for you in one place at a central system. That this is also lowering the time needed to acquire all this data, and also having a direct impact on lowering the costs of production and workforce. Being that this is an automated system, all of this data is archived and stored into a central place, so you can always revisit it and reanalyze any event that you might see fit. It's easier to detect peaks and irregularities because you can see them as they happen, and you can revisit them and analyze over and over again if needed. This is, how I say, a first stone that you need to overpass to be able to implement the ISO 50001 standard. Also, as being said before, Zenon software platform is a diverse system which can communicate with various equipment, various softwares, various databases and systems like SQL, ERP, SAP, and such systems. But what we did for Carlsberg, okay, you have metering devices all over the plant, but where are they and how are they interconnected? Does this pipeline go strictly to one place of the factory, or do you have something else connected to it? In our part of the world, systems are ever growing, and not always the documentation covers everything installed. So it's nice to have an overview, a topology view of every consumer in a way that's easier to understand for the maintenance personnel. As I said, all data is acquired, archived, and represented in a form of graphical displays as a trend diagram. You can see how your system behaves. Of course, you can change the time scope of your needs. Being that this is a custom built solution, we can represent the data in any way or shape or form the user is used to or has the need to. You can always make it more graphical or less graphical in a tabular form. You can also, it's not limited just to metering devices. You can also communicate with machines and get data from the machines, get their KPIs and such. I don't want to read this. You can read it by yourself, but the important thing is that we developed a system that facilitated in vital work tasks. So the personnel using the system can always rely on it. They have access to it at any given point in time, whether on-site or off-site. And the sheer power of analytics makes the everyday tasks easier for the supervisors and the operators. Also, it's important to say that having the data comprised and compressed in a way and analyzed, so the maintenance team can, at a glimpse, see what's wrong with the system. They don't need to spend hours and hours. They can directly and focus on the task at hand. So it's making their job a lot easier. Topic is wide. I'm open to questions. If you have my contacts, you can send us email or you can post your questions in the Q&A session. Thank you very much.
Thank you, Bojan, for showing us this interesting project. Let's continue with machine management. I would like to welcome our next guest speaker, Matej Močnik from INDBUS, who will talk about Inspector, which is a system of sampling and quality control integration. Welcome, Matej.
Thank you. Okay, so first, hello to everyone listening on this webinar. Let me just spend a few words about our company, INDBUS, before moving on to the actual application. I'll try to be quick. So INDBUS employs experts in the field of mechanical, electrical, and software engineering. Together among us, we have several years of experience in industrial manufacturing and control processes, automation, robotics, digitalization, and informatics. We work as closely as possible with our customers to offer them comprehensive services from the development of conceptual solutions, consulting, design, construction, manufacturing, and installation, all the way to electrification, programming, and at the end, of course, commissioning of machines and devices. We work both on well-defined and, let's say, turnkey solutions that have a specific machine in mind, as well as research and development projects with specific customers. We focus mainly on, let's say, design and manufacturing of more high-end or high-tech machines, devices, and solutions in the field of mostly biotechnology, pharmacy, and of course, food industry. But of course, we don't exclude other markets. So that's about us. So what you see here is the product that I'm going to talk about, or let's say a system. It's Inspector. This is the product and Zenon use case that I'm presenting, and it was developed in-house as a system of sampling and quality control integration. The system has been developed initially in the food and beverage industrial environment, and the examples I'll be showing in the presentational material are also from this environment. However, given the general applicable approach to the task of quality control, I think that the system is usable broadly in other fields too, practically anywhere. The picture of the device on the right is just an example of how a standalone version of Inspector can be configured, but it's practically a modular system, so it can take various forms actually. So we'll quickly go through a short description, the system structure overview, and then of course its feature set, what can be done with such a system. So Inspector can function as a standalone device. This is the leftmost position, as an add-on to pre-existing machinery, the middle position, or it can be used as part of a production line equipment, thus enabling integration of product sampling and quality control with production processes. In other words, it's not just a single form of a device or application, but a system of components that enables integrating the necessary tools and procedures for sampling and quality control into a production overflow. So Inspector is in short designed firstly as a mobile device that can be positioned next to a production line at special points of interest or specific workplaces. It has a collaborative robotic arm with tooling that obtains samples and prepares measuring sensors. And the measurements that it makes are then analyzed, and then, well, the product quality is judged based on product specification, tolerance limits, recipes, settings of the workflow, and of course, let's say the limits of the operator that are set to the machine. The results of the processes are presented as first as live statistical data on the screen of the inspector itself, and of course as historical reports, and the reactions based on the results can take form as either alerting and correction feedback, or of course as local signaling to the machine itself with let's say semaphores, buzzers, lights, and so on. So let's take a look at the system structure. The physical part of Inspector is made of, as you see, a mobile device base, which is the lower part, then a collaborative robotic arm displayed here. This is a, let's say, a universal robot, collaborative robotic arm, but we can use also too. Other producers are not excluded from this system. Then it has a set of tools for sample extractions, such as, let's say, grippers, suction cups, vices, snippers, soft mechanical grippers, etc. Here you have on the picture some suction cups. Then it includes a set of sensors and cameras, including, of course, also temperature probes, weight loading cells, 2D cameras, 3D cameras, and infrared cameras, of course, and other. All of which are also on the robotic arm or at the back of the mobile device base, because we have space for sensors here at the top of the robotic arm, and we specifically reserve some space at the back of the machine where we can position specific, let's say, analyzers or measurement systems, for example, evaporators, weighing cells, and so on. Of course, there's also industrial PC. It's integrated in the mobile base right underneath the machine, and this industrial PC is used to run the system, to connect it to other machinery, and of course to execute the Xenon platform. So then on the lower left part, you can see it here. We have this logical structural diagram that actually shows how the software part of the system is composed, and here we see how Xenon comes into play. So the software is composed of, let's say, our proprietary sensor measurement acquisition that connects and gathers data from all the sensors connected to it directly. We have our proprietary 2D and 3D vision system that works with all the cameras integrated on the system and provides results from system vision analysis. Then we have our proprietary collaborative robot manipulator guidance system that coordinates the position of the robotic arm with the necessary operation, takes care of moving the robotic arm correctly to, let's say, take the samples from the production lines or to move the sensors that are necessary to make the measurements. Then moving to Xenon, we have firstly the use of drivers from Xenon that we use to communicate with a number of machinery PLCs. Then we incorporated our specific add-ons for data analysis and judgment directly into Xenon. And of course, we use Xenon for our main graphical user interface, taking advantage of the data historian, the reporting engine, and also of its alerting services. So that's, let's say, broadly an overview of the system of Inspector. Now let's take a look at the feature set. This is, let's say, a list or a set of measurements and functions that can be performed, and it's quite extensive. In fact, Inspector can be equipped with a number of sensors, as I already mentioned, cameras and other measuring devices, and the feature set depends on the actual equipment. And the measurement can be performed also depends, of course, on the location of the machine, because, as I said, this is a mobile device, and for example, on certain positions along the production line, only a certain number of measurements can be made. So let's just take a look at a couple of them and how they look on the Zenon interface. So for example, for dimensional measurements such as length and width, you can see the results here on the right side in the graphical interface. We also have height and volume measurements, but this is only possible when we integrate the 3D camera. The contour lines that you actually see on the picture are a representation of 3D data of this object that we scanned for the quality control. I don't know if you recognize it, but this is just a sweet roll on a production line for sweets. Then we have temperature measurements. Right here on the right side, we have a sample of Kaiserbahn, which is taken with an infrared camera. We measure the outside skin or crust temperature, the internal core temperature, which we measure with an insertion probe, because using this robotic arm, we are able to, let's say, track a certain product and also insert measurement devices into the product and then take it away or release it along the line. And of course, inspector also does mass measurements using a load cell inside the robotic arm or at the back of the mobile base. And it also can perform color measurement analysis, such as, let's say, blemishes or color unevenness or even color gradients if our customer needs such a device. For example, this is used in, let's say, bakery products analysis to ascertain if the product is baked well enough, too much, or underbaked, or so on. So going further, as I said, the feature set is quite expensive, so I'll just go through this quickly. The usual chemical measurements that we have done for food and beverage are usually humidity or moisture constant. It's displayed here on the right side. Then, of course, pH, or some prefer to call it acidity, and fat content. I'll also note on this picture that we keep the history of sample measurements and enable the user to rebrowse through them for review, of course, at any time. We do this using a combination of Zenon trends and reporting, depending on the type of the measurement. Of course, some data can't be represented as bar graphs, but just as linear graphs and so on. Then we have shape analysis using our vision system for, in this sample shown here, for symmetry, concavity, and pattern matching, but we can also do pattern matching and shape matching both in 2D and 3D. So in the end, there are several also specialized analyses that are based on specific product requirements. These are usually some sort of feature counting. For example, we sometimes need to count seeds on the products, cuts, or let's say decoration on bakery products or on sweet products, and also special markings on top of the products and so on. Then we have total product counting when performing continuous measuring. Complete 3D shape recreation is also possible, but this usually takes quite a lot of time because the product needs to be scanned from various positions. Then we have calculation of humidity or moisture loss based on relative weight change. For example, if we are able to track the product along the line on various positions along the line, we're able to calculate and also show the operator how much humidity was lost along the productions and so on. And finally, specific product defect location can be performed if there's some specific, let's say, shape or some specific part of the product that needs to be checked or made sure that it's either present or not present. That's also a feature that can be checked. So naturally, our customers can request other measurements too and analysis because the system is open to implement new quality control procedures. So another important, and for the purposes of this presentation, also final part of Inspector feature set is how it interacts with its environment. The picture of the Zenon interface on the right shows a location map or a layout of places where the inspector can be located for this application. It's just shown for this sample production line that was implemented with this system. Mobility and location determination are in fact an important part of the product, actually also for our customers, because inspector can be repositioned to perform sampling and measurement on different locations along a production line. It can be installed at a fixed location to perform complete production quality control if a customer wants to do so, but this is usually when there are high volumes production and the quality control requires to be made on each product, not just on sampling based. So location can optionally be entered manually through the very same layout that you see on the interface, or it can be determined using self-locating methods such as we use RFID or QR code samples or visual cues and other location possibilities. A set of appropriate procedures can also be associated with the specific location. So for example, if the inspector is positioned on a specific workplace, only a certain set of quality controls are selected to be done on that position, depending on the production line itself. And moving on from location, alerting is a way for inspector to make the results of its procedures known. So when some results are available and they're either within the limits or go out of them, the user can be alerted. And this can be produced with either using Zenon alerting methods such as emails, SMS, messages, or phone calls. But of course, we also do local alerting via the sound and visual signals, semaphores, horns, and so on, just to make the customer know that something was produced out of the tolerances, or that, for example, a production cycle was finished or reached a certain goal. And as the most integrated and oftentimes also the most effective solution of the system is correction feedback, which can be performed by communicating with diverse machine PLCs, of course, taking advantage of Zenon's drivers. And this enables us to perform actual control feedback loops using all the arsenal of the measurements and analysis that I just described to drive some control loop, to change some parameters or increase, decrease values that the operators can then follow and see what happened during the production. So with the combination of our engineering, the software modules, and Zenon features, I think we've been able to construct a highly effective system for quality control, and also a system that's mobile and adaptable enough for practically any position along a production line. And I think that's in brief it about the inspector. If you have any question or are interested in our product, don't hesitate to either contact me or write in the chat box or let me know. Thank you. And back to Anka.
Thank you, Matej. This was super interesting. So let's hurry to our next part, reporting with Zenon. I'm inviting our next speaker, Nicola Maric from XR80. Hi, Nicola, welcome.
Hello. Let me just share it real quick. Yeah, I will be showing you some reporting in Zenon. The reports that I will be showing are from the reporting engine formerly known as a Zenon Analyzer. And as we're kind of short on time, I will just begin. So the first reports that I will be showing are the ISO 50001 reports. And to be more specific, it's the energy costs, cost per machine report. So here we can see it's a time period of an hour. And we have pie chart where we can see the for each machine, a filler, a labeler, a packer, a pasteurizer, and how much did running that specific machine cost in the given time period. So for instance, here we see that the pasteurizer cost 82 euros and 62 cents to run. And we have some extra information with relative costs for each machine in this report. The next report that I wanted to show is the energy cost main consumers, detailed. Here we have, I think, a little bit of a bigger time period. It's 3 hours. And we can see the consumption per area, so how much energy was consumed in the pallets area, in the crates area, bottles area, and energy consumption per 1,000 bottles. And we have some pie charts as well. On the right here, we have the in kilowatt hours energy and the same calculations for the same areas in euros. And at the bottom, we have it summarized. This is every 30 minutes in the given time span of 3 hours. And at the bottom, a sum of energy consumption in the pallets, crates, bottles, total energy consumption. We have here total energy costs, energy consumption per 1,000 bottles, then good bottles, and the total amount of bottles produced. The next report, I will be switching to the so-called 360 reports. 360 reports are reports that contain multiple different, how do you say, report templates at the same time. So here we can see the overall efficiency analysis report. Its time span is, I think 6 hours, and we can see the media consumption, for instance, energy consumption, water consumption, compressed air consumption, and we can see in which category each one fits, and efficiency class name, and in which efficiency class our water consumption fits. For instance, in this report, it's C. The same for compressed air and energy. And at the bottom, we have the media consumption per hour. So we can see for each hour how much of each media was consumed. The next one is the plant analysis report. And here we have first at the top some alarms that happened. Afterwards, there's the compressor efficiency. Again, an efficiency class table, efficiency class, a graph of energy consumption, and a table at the bottom showing us some values for specific time periods. And the last report I am going to show is the production analysis report. The production analysis report, this is for 10 minutes. And here first we have a Gantt chart saying the state of each machine and operating, when it was operating, when it was stopped, and so on. On the right, we have the availability, performance, it's an overall equipment efficiency. Afterwards, we have a waterfall chart and the losses analysis. So we can see how much was gone to speed losses, minor stops, breakdowns, cleaning, unplanned breaks, and so on. And afterwards, we have some aggregated tables. We can see some extra information if we're interested, and an indicator table as well. So that's basically it for reporting. I hope we have enough time for the Q&A session as well. Thank you very much. Back to you, Anka.
Thank you, Nicola, for showing us these reports. Okay, we have answered the majority of the questions during the webinar already. We have 2 more left. We will quickly answer them. First one is for our guest speaker, Bojan. how long did it take to implement energy management system in Carlsberg?
Thank you for the question. Well, it began with just a few devices at first, and it's an ever-growing project. But to get where it is today, it took about 2 or 3 months. But it also depends on the scope of the project. You can, it depends. You have to analyze the system and then give a time span as to how long it would take to implement such a system. And it's a constantly growing system. So it's basically an ongoing project. I hope that answers the question.
Great, thank you so much. And another question, I think this one is for Dalibor. Is MTP already implemented in a real project?
Yeah, thanks for the question. As I mentioned at the beginning, we have already 60 polls, but the most important is that it's already implemented in Merck in Germany. So you can find more information in the recordings of zenon-as event. Co-creator presented this very thoroughly a few months ago, and I can share a link also for this recording. This is the first, of course, ongoing project. MTP it's not still finished standard. It's developing all the time. So co-creator is following and implementing every instance when everything is improved. I hope this is an answer for this question.
Thank you, Dalibor. Okay, so this is it for today. If you will have any more questions, just contact us to these email addresses here. We will be happy to help you and answer everything. Thank you so much for joining us today. And especially thank you to all of our speakers and guest speakers. This is also the last webinar for this year. So we wish you happy holidays and see you next year. Oh, and don't forget about the survey. Please fill it out. We want to hear your feedback, and the recording will be sent to you to your email address in the following days. Thank you again, and see you next time.
Thanks. Bye.
Bye-bye.